Hi, Assalamualaikum. Today we're going to learn about the absolute value and also the inequalities which involve the absolute value. Right. So usually we have the absolute value be represented by this modulus a, and it is actually equal to the square root of a square. So usually when we write square root of a square, it's not actually equal to a, but it's actually equal to the modulus of a. Right. So and this modulus of a can be represented by this piecewise function, where it is actually equal to a if a is greater than or equal to 0, and it is actually negative a when a is less than 0. Right, let's look at this example. We know that when we have the modulus, so to remove that modulus we need to have the plus and minus. Therefore this is actually x plus 1, which is equal to plus minus 3. So we have the x plus 1, which is equal to 3, another one which is x plus 1, which is equal to negative 3. Solving this, we have x 3 minus 1, so we have x equal to 2, but this one x is equal to negative 3 minus 1, therefore we'll have x equal to negative 4. Easy, right? So we have two answers here, right? If we substitute, or just to illustrate what does this absolute value means, suppose we substitute 2, so 2 plus 1 will be 3. If we substitute with negative 4, so negative 4 plus 1 will be negative 3, but because it is modulus, and modulus of negative 3 will be 3. So we can have these two answers, alright? Either x equal to 2 or x equal to negative 4. Okay. Now, suppose we have to solve this what do we call equations involving the modulus. So what we need to do is actually to try to remove the plus and minus. Alright, so because I have the coefficient 2 here, so I want to make the plus minus on this side, so we choose either one side only, right? So we have the what do we call alright, suppose I have now I want to remove the modulus, so I have something like, sorry, not using this color, x minus 3, which is equal to 2, 1 minus 5x. Please note that I'm going to put the plus minus on these sides, right? Another one will be negative of x minus 3, because this is a positive part. Alright, so this is will be 2, 1 minus 5x. This part is unchanged, right? You just put the plus and minus on only one side. So we try to solve this one. We'll have something like x minus 3, 2 minus 10x. Alright, so we'll have something like we bring that what do we call this negative 10x to the left side, so therefore we have 11x is equal to 2 plus 3 will be 5, therefore x is equal to 5 over 11. Right, another one we have to solve, this one will be negative x plus 3. Right, we'll have 2 minus 10x, therefore we'll have 10x minus x will be 9x, right? Which is equal to 2 minus 3, right? 2 minus 3 will be negative 1, therefore we'll have x equal to negative 1 over 9. So we'll have two answers here, right? It's either x equal to 5 over 11 or x equal to negative 1 over 9. Now let's go to this one. We need to solve these equations, so we can have this either, so we're going to put the plus minus on these sides, right? So we'll have something like x minus 4 over 2x plus 1 will be equal to positive 3. Another one will have x minus 4 over 2x plus 1 will be equal to negative 3. And then we have to solve these equations. So this is just a linear equations, right? So you will have something like, okay, x minus 4, which is equal to 3, 2x plus 1. All right, you expand that one will be 6x, right? 6x plus 3, therefore we have the negative 5x, because I bring 6x to the left side, therefore I have negative 5x. 3 plus 4 it will be 7, therefore I have x is equal to negative 7 over 5. Right, now we are done with this one. Next we need to solve this one. We'll have something like x minus 4, which is equal to negative 3, 2x plus 1, therefore we will have something like x minus 4, expand that one will be negative 6x minus 3, and then combine collect all those terms with x at the left side, therefore we have 7x equal to 4 minus 3 will be 1, therefore x is equal to 1 over 7. So we have two answers here. Alright, let's now solve this example 4 here. Suppose we have the modulus on one side, another one side will be the square root. So remember, when we have this type of questions, we have to change this modulus into something square root, because we have that modulus of x is actually square root of x squared. Right, so we have to change this modulus of x minus 1 will be x minus 1 square. So this is equal to 7 minus x. So to remove the square root on both sides, we have to take square. Right, so now when we take square, we are left with x minus 1 square equal to 7 minus x, which is this part only. Yes. All right, now we have that we expand that one, x squared minus 2x plus 1 will be equal to 7 minus x, and then you have to bring all terms to the left side so that we can have it in the general form of the quadratic equations. So we have something like x squared minus 2x plus x, right, plus 1 minus 7 will be equal to 0. And then we solve this one. We simplify first. All right, so we have minus 6, which is equal to 0. We will have to factorize this. This is actually equal to plus 3. Yes, plus 3 minus 3. All right, x minus 3x plus 2 equal to 0. Okay, now we have that x minus 3 equal to 0. Another one, x plus 2, which is equal to 0. So we have the answer, x which is equal to 3, or x equal to negative 2. So these are two answers for this one. Right, now let's go to this one. Right, so we go to the concept of inequalities. Now we're going to solve the inequalities which involve the absolute value. Right, you should know that when we have modulus of x which is less than the value a, then we will have that x is actually between negative a and a. But if we have modulus of x is greater than a, therefore we have something like x which is greater than a union with, right, I'm gonna write less than x less than negative a, when union with x greater than a. So when we represent this, actually we have something like negative a with a. So it is somewhere around like something like this. All right, but for this part we have negative a and a, so it goes this way, and this one goes this way. All right, this is what it means by this inequality. Okay, now we need to solve this inequality. So what we need to do is actually, right, to use this theorem. So we know that when we have this is less than, therefore this can be written as, you know, 2x plus 1, which is between negative 7 and 7, because they are both values on the left and right, therefore we can solve simultaneously. If you want to break it down, also okay, but if you want to solve simultaneously, also okay. Now I want to bring the positive 1 to the left and right side, therefore I will have negative 7 minus 1 less than 2x, which is 7 minus 1. So I will have something like negative 8 between 2x, all right, and 7 minus 1 will be 6. Therefore I want to remove 2, so I have divide 2 on every side, so I have something like x which is less than negative 4 and less than 6. So if the question asks you to write in the real number line, therefore we have something like negative 4 and 6, because we don't have the equality symbol here, therefore negative 4 and 6 are not included. All right, okay, now let's go to example number 6 here. Suppose we have this type of inequality. So recall that when we have one modulus of x which is greater than a, then we will have something like x is less than negative a, or x is greater than a. So what we need to do is to break this into two parts. So the first part, which is 3x minus 5, which is less than negative 16, or union with the 3x minus 5, which is greater than 16. All right, now we have to solve this. All right, so 3x minus Right, so negative 16 plus 5, so I have 3x which is less than negative 11, therefore I have x which is less than negative 11 over 3. But for this one, we'll have something like 3x which is greater than 16 plus 5, 3x which is greater than 21, so x which is greater than 7. So I have the this one is union. Right, so suppose we want to write the final answer, will be something like x which is less than 11 over 3 union with x which is greater than 7, or we can represent this on the real number line. So we'll have something like this, so this part going this way and this one going this way. So we are done. I'm sorry. Because this is, we have equality symbol, so please write the equality symbol. All right, so I'm sorry. So now this is the equality symbol, so it should be full circle here. Okay, all right, now let's solve this one. So can we directly, all right, make the what we call less than negative 9 and greater than 9? No, actually we have to collect all those without modulus on one side and put those with modulus on one side. So meaning to say that we have to bring this negative 4 to this side. Therefore we will have something like modulus of 2x plus 7, right, which is greater than 9 plus 4. And then simplify this, we'll have something like modulus of 2x plus 7 which is greater than 13. All right, so we have to solve this using the previous theorem. We know that when it is actually greater than here, so we have 2x plus 7. Right now I want to bring out that modulus, so I have less than negative 13, or right 2x plus 7 which is greater than 13. Okay, now we need to solve this one by one. So this one, negative 13 minus 7, I have 2x which is less than negative 20, therefore I have x which is less than negative 10. But for this one we'll have something like x 13 minus 7, so 2x 13 minus 7 will be 6, therefore I have x which is greater than 3. So this is union. This is the final answer for the inequality form. But if you want to write it in the real number line, therefore I have negative 10 here and 3 here. So alright, we don't have the equality symbol, so it goes this way for this one, and this one goes this way. Right, now suppose we have example 8 here. Alright, we have 2 here. What we need to do, we collect those constants on one side, so meaning to say that I have to bring 2 to this side. Right, so we'll have something like 4x plus 1, so 18 over 2. 18 over 2 is actually 9. Okay, you bring 2 on the right side, therefore you divide it. So we have something like this. Therefore using the theorem we know that to remove that absolute function, therefore we have something like which is between 9 and greater than equal to negative 9. We can solve simultaneously, meaning to say that we can bring that one positive one on the right side and also on the left side. Therefore we will have something like 4x which is less than 9 minus 1, and this one is greater than negative 9 minus 1. Alright, we have 4x which is less than 8, and this one greater than equal to negative 10. Therefore we divide with 4. Now we want to divide with 4, so we are left with x which is between negative 5 over 2, and this one will be between 2. Using the real number lines, and negative 5 over 2, and this one is 2 because that one is included. We have equality symbol, that's why we have full circle here. Right, let's go to example number 9. Suppose we have this. Alright, so what our intention is to put those constants on one side. Therefore we have something like 2 over 5. We exchange the position between these two, so that we have the numbers together with the numbers, and the absolute value, absolute function will be on the right side here. Alright, so we know, alright, if we do it over 5 which is less than this, so meaning to say that x minus 3, I just want to change the position. Of course this one will be greater than or equal to. So using the previous theorem we know that x, to remove the modulus, right, modulus symbol here, we have this one less than or equal to negative 2 over 5, or we have x minus 3 which is greater than or equal to 2 over 5. Right now we have to bring negative 3 on the left side, therefore we have negative 2 over 5 plus 3. This one will have x which is greater than 2 over 5 plus 3. So we have to solve this one. Sorry, this one is less than or equal to, so negative 2 over 5, all right, plus with 3 we get what do we call 13 over 5. But for that one, 2 over 5 plus with 3, therefore we will have x which is greater than 17 over 5. Right now this is union. All right, if you want to represent the real number line, they have something like 13 over 5 and 17 over 5. Therefore, because they have the equality symbol, therefore we can have the full circle here, but it goes this way. Yes, right. But can x be equal to 3? Cannot. All right, look at this. X cannot be equal to 3, right? So bear in mind that in early, from the beginning x cannot be equal to 3, because when x is equal to 3 it will be undefined. Therefore at 3 it should not be defined. So we have something like this. Okay, it goes this way and it goes this way. It cannot be equal to 3. All right. Okay, we are done with that one. Let's go to example number 10. Suppose we have this. What we should do is to bring this negative 2 to the right side, right? So we'll have something like x over 3 plus 1. All right, when we bring negative 10 over negative 2, will the symbol change? Yes, because we divide with the negative number. So dividing with negative number will change the position. All right, so we have something like x over 3 plus 1 will less than 5. Using the theorem, x over 3 plus 1 is between 5 and negative 5. All right, now we want to bring this 1 to the right and also to the left. So we have something like x over 3 which is less than 5 minus 1 greater than negative 5 minus 1. Therefore we have x over 3 which is between 4, all right, and negative 6, multiplying this 3 on both sides. All right, multiplying, because 3 is a positive number, so the symbol does not change. Therefore we have something like between 12, all right, and negative 18. All right, so we have our what do we call real number line, which is something like this. Okay, we got this one. Okay, now let's go to this one. All right, what if we have something like this? Therefore we have to bring 8 to the right side together with 6. We have something like negative 2x minus 1 which is greater than or equal to 6 minus 8, right? So a negative 2x minus 1 which is greater than or equal to negative 2. Okay, now I want to remove this negative, so I will have something like 2x minus 1 which is less than or equal to 2. I'll multiply negative 1 on both sides, so the symbol will change. Now using the theorem, alright, so 2x minus 1 is between 2 and also negative 2. To remove that negative 1, we have to bring to the right side and the left side. Therefore we will have 2x which is between 2 plus 1. This one negative 2 plus 1. Right, 2x is between 3, right, and also negative 1. So to remove 2, you have to bring 2 on both sides. Right, you have to bring these 2 on both sides. Divide every side with 2. Therefore dividing this with 2, we'll have something like x is between negative 1 over 2 and 3 over 2. Therefore we'll have something like negative 1 over 2 and 3 over 2, because it's in between. It's something like this. Okay, we are done with this one. Easy, right? No problem, I guess. Now let's go to this one. How to solve this one? Suppose we have the inequality with one side is modulus, another one side is a square root. So actually we have to transform this into the square root form, because we already recall that modulus of a is actually square root of a square, something like this. So we change this part into the square root form, so we'll have something like x minus 3 squared, which is less than square root of 3 minus x. Alright, now we want to square both sides, so we square both sides, therefore we are left with this part only. Alright, so we have something like x minus 3 squared, which is less than 3 minus x. So now we expand this one, we'll have something like x squared minus 6x plus 9, which is less than 3 minus x. You bring all those terms to the right side. Alright, now we have something like x squared minus 6x, I bring negative x, will be plus x, plus 9 minus 3, which is less than 0, because we bring everything to the left side. Simplifying this, we'll have x squared minus 5x plus with 6, which is less than 0. Recall, if we have this quadratic inequality, what we need to do is to factorize. So we have x minus 2, x minus 3, less than 0. Right, x minus 2 and x minus 3. What we need to do is to recall that we have to identify the critical values. Critical value, therefore it is actually at 2 and also 3. So we have this number line 2 and 3. We have to find the interval for these three parts here. So we know that we have this as negative infinity up to 2, from 2 up to 3, from 3 up to infinity. Right, so first that one is the interval, so we have to take the test value. Right, put any value that is in that interval. So suppose I choose 0, I choose 2.5, I choose here 4. Right, now we put in the factor x minus 2, x minus 3, then we'll see the result for the x minus 2 and x minus 3. Alright, so if we substitute with 0, alright, with 0 here, so what will happen? We will have 0 minus 2 will be negative, so 0 minus 2 will be negative, 3 will be negative. 2.5 will be positive, substitute with 2.5 will be negative. Substitute 4 will give positive, substitute 4 will give you positive. Therefore this one will be positive, negative, positive. But we want it to be, alright, recall that our inequality, final inequality, we want it to be less than 0. So less than 0 is negative, so this is the answer. So our answer, alright, is actually 2 and 3. Are 2 and 3 included? No, because we don't have the inequality symbol there. Alright, so we don't have equality symbol, therefore 2 and 3 are not included. We have the bracket here. Alright, now let's go to the last example, I guess. Alright, last example here. Suppose we have this inequality with both sides a modulus. So what we need to do is to change both modulus into the square root. So we have x plus 2 square, right, which is less than negative. We change this part only, so square root of x minus 3 square. Okay, now to remove the square root, we have to square both sides. So when we square this, we'll have something like, alright, this one left with x plus 2 square less than negative means negative 1. So when negative 1 is squared, so we get positive 1. So now we are left with this part only. Alright, so x minus 3 square. Okay, So now we have to expand the square. We'll have something like x squared plus 4x plus 4, which is less than x squared, what do you call, minus 6x plus 9 here, right? Minus 6x plus 9. Therefore, we will have something like, all right, that one, you bring all those terms to the left side. X squared minus x squared becomes 0 plus 4x, plus 4x plus 6x, and you have plus 4 minus 9, which is less than 0. Okay, something like this. So x squared and x squared has already been cancelled. So we have 10x, which is 10x minus 5, right? 10x minus 5, which is less than 0. To solve this one, bring that 5 to the right side. So x will be 5 over 10, where x is less than 1 over 2. Therefore, we will have this on the real number line, 1 over 2, x is less than it, so we go to these sides. So that's basically how to solve the linear inequalities involving the modulus functions. So that's it. Thank you for watching this video.